All right, today we're going to do 3.8, the tangent function. So let's get to it. So that's the circular angle right there with the theta over here. If you remember from the earlier lesson, we learned that tangent is the y over x value. That's how we find it on the unit circle. So extend to that, we can also say that tangent is sine over cosine. Another way I want you to think about it is this. If it's a y over x, can I say that tangent is the slope of this line over here? What do you guys think about that? Slope of that terminal ray. Makes sense, right? Okay, so we're going to approach it more of as a slope to build a tangent function for today's lesson. So right here, slope of a terminal ray. Yay? All right, why is it so small? And blurry. There we go. All right, as we did previously with the sine and cosine, by the way, those have the sinusoidal function with the wavy. We can use our understanding of the tangent function to develop its graph. Let's take a look at the slope of a terminal ray as our angle goes from 0 to pi over 2. All right, so when the theta is 0, the terminal ray right here, what is the slope of this line right here? 0, right? You can actually use a unit circle if you want. That has a coordinate of 1, 0. Oops, 1, 0. So y over x is 0. Either way, you get 0. Okay? Now, what happens as theta gets bigger, all the way closer to pi over 2? Just tell me what happens in terms of slope. What happens? First of all, it's a positive slope. You good? Positive, more positive, more positive, more positive. So your slope gets bigger, positive. Steeper, steeper, steeper. Are you all with me? And by the time it gets to pi over 2, which is half the pi up there, what's the slope of this? What's the slope of this line right here? Well, I can't find it, right? Or you can just say that's a 0, 1. What is 1 over 0? Undefined. So when theta is pi over 2, the terminal ray is now vertical. The slope of this vertical line is undefined. All right, so here's what I'm going to do. I'm going to take the slope of all the way from 0 till pi over 2, and I'm going to graph that. Ready? Ready? Boop, right here. Okay, right here. From 0 to pi over 2. Sorry, I'm at home. Pi over 2 right there. Okay, so at 0, which is on the positive x-axis, the slope was 0 right here. And then you got bigger, positive, very positive. But then as soon as you hit the pi over 2, it was undefined. So I'm going to put the asymptote at pi over 2. So there it is. That's your first quadrant of the tangent function. Does that kind of make sense? Okay, all right. Now then, what about the next quadrant? Pi over 2 to pi. It's supposed to be color, but my printer is a mess. Everything's a mess. That's okay. All right. Look at this line right here. As soon as it's a little more bigger than pi over 2, is that a positive slope or a negative slope? Positive slope or negative slope? That's a very negative slope, right? So like I can exaggerate that has a slope of negative 100. I know I'm exaggerating, but just bear with me. What about this? Maybe like negative 5, negative 10-ish? Exaggerate. Ooh, that kind of looks like negative 1. Okay, negative like half-ish. So it's a very negative, but it gets bigger. And then when it reaches the pi, what's the slope at pi? 0. So from half the pi to pi, it becomes very negative to closer to 0. Go back over here. Half the pi to pi. Oops. As soon as you step away from half the pi, it's a very negative tangent value. Gets closer to 0. And at pi, it is 0. That's your second quadrant tangent right there. Tangent value right there. All right. Can't you guess what we're doing next? Yeah. Third quadrant. Boop, boop. All right, look at all your slope. That's a positive slope, right? It's increasing from left to right, so it's a positive slope. But what about this? That's a very small positive. So I'm going to say, because remember at pi it was 0, so like maybe like very small positive. Half or fourth, very small. And it gets bigger, 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 200 maybe. And then when it reaches pi over 3 pi over 2, excuse me, that's a vertical line. So what's the slope over here? Undefined. Since it's a 0, negative 1, negative 1 over 0 is undefined. Got it? Alright, so where's that? Underneath it? Pi to 3/2 to pi. So it's 0 to getting very small, small is positive, get bigger, 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 bigger to 100, 100, 200. But then as soon as it reaches the 3/2 to pi, there's a vertical asymptote. Alright, so every time the terminal ray is vertical, where were they? The pi over 2, the top, and then 3/2 to pi, you're going to see the vertical asymptote. I'm too lazy. Vertical asymptote. When theta is pi over 2 and 3/2 to pi. So, since it's vertical asymptote there, let's draw our vertical asymptote at 1/2 to pi and 3/2 to pi. And then can't you find all the coterminal angle of those, right? So you can subtract pi. So there are vertical asymptote happening everywhere. It is a periodic function. Tangent is a periodic function. And there you go. Okay. So that's how you build it. Now let's talk about the features of those in the next video.